Okay, welcome back. I realized that the previous video was too long and I'm trying to break it up into a little bit of a bite-sized chunk. So I decided to just go ahead and stop it and then come up with a different video so we can just start fresh. All right, now coming back to the regularly scheduled program. So now that we have this equation of moment, we know that our moment is going to be 9 kilonewton per meter. Now, this is at middle of beam. Now, because it's a triangular load that's diminishing, it will change as you move across the beam because the loadings on each part of the beam are so different. So that's something that we should keep in mind. All right, so now that we found a moment, let's go ahead and keep going. So we're going to sum forces in the y direction. And we'll say that By, which is as positive, plus V minus 3 kilonewtons, which is from the distributed load, is equal to 0. We know that By is 4 kilonewtons, so that means that our V is 4 minus 3, but it's going on the other side, it's going to be negative 1 kilonewton. All that means is that in the direction V is 1 kilonewton, and it's actually going down. Okay, so before from our moment is, since it's positive, is still going counterclockwise, just like we drew it. And then finally we have our sum of forces in the x direction. So then our n, or our normal force, is equal to 0. I'm going to go ahead and put some bars so we can see our answers. Let them pop out a little bit more, and that's important later. Okay, so now that we're done, we're just gonna go ahead and continue. So the next step is, if let's say we're looking for normal stresses and normal and shear stress. Okay, so we'll say that our normal stress is N over A and our shear stress is V over A. In this case, because we don't have there's no normal stress, it just means that our average normal stress is equal to, so that is sigma is equal to 0. And then assuming that our area of the whole bar, which is a cross-sectional area, is 5 millimeter squared, which, if you're trying to find it, it's 5 divided by 1,000 squared. It's pretty small. Now this stuff I'm making up in my mind, so bear with me, okay? -6, and that is meter squared. So if we have our shear stress is going to be our shear force, which is 1 kilonewton or 1,000 newtons, divided by 5 times 10 to the minus 6 meters squared. So 1,000 can give us a really huge number, which is 200 million, or 200 MPa. And that's the answer. So to quickly cover this, what we have is that if you're given some kind of beam or structure and you have to find the internal shear moment, I'm going to go ahead and find shear and normal stress. And this applies to every single example that is available on Blackboard. Is that what you have to do is find the support reactions, and that's the first step because any external support or load is going to affect our system. So find our support reactions, which you do by drawing the free body diagram, finding AY, BY, and AX as needed. And what you go ahead and do is, in order to find the internal moment and shear, you make a cut depending on where you want to make the cut, right? So if, for example, this wasn't given, but if you're asked to make a cut 1.5 meters away from B, that's where that's going to be, and that's example 1.9. So you make a cut in the middle, and which means that there's going to be some kind of shear, there's going to be a moment, and then maybe there's going to be some normal force as well. So once you make a cut, remember that depending on the kind of load it is, that make the adjustment too. You find your moment, and then you find your shear, and you find your normal force as well. Now, because your shear depends on normal stress in this example only. Your normal stress only depends on N in this example, chapter 1. We're going to say that your normal stress from N, from your normal force, is equal to 0, and then your shear is equal to shear stress is equal to shear over A. Now in the future, you will see that you could find normal stress. Say you can find normal stress from other ways, including moment. But that's something for another day. So I'm hoping that this quick video kind of gives you a quick glimpse into what we're trying to do. Later on today, I'm going to do a couple of examples that are available on Blackboard as well, just to kind of help walk you through it. And then hopefully you can use that to read your book and be able to solve some problems on your own. Remember that we have a quiz on Wednesday, and then we also have homework that is available right now and it will be due next Sunday night. Please let me know if you have any questions, okay? Have a good week.